now about handling the data. We've had
Yeah.
our returns on our survey. Hopefully we've had a good response rate.
Mm-hmm.
So what do I do now?
Well, you can't analyze it on paper. It's just too clumsy and awkward. So what we do is we enter the data into what is in effect a giant spreadsheet, where every row is a single person and every column is an answer to each question on the survey. And we usually enter a code, a number, or a letter rather than the actual response. We don't enter strongly agree. We put 6 or 5, whatever number represents that. Having entered that, we need to check that we didn't make mistakes by going from paper onto the computer screen. If you've used an online survey tool, you can be pretty confident that when the person clicked on a strongly agree and it comes back to you as a 5, well, that 5 is what they actually clicked. For paper, it's possible that the person entering got it wrong, that one was really meant to be a 5. And so you need to do checking. If they say they work in, that they are a student in the XYZ Boys College, you want to be sure that they've ticked the column boy, not girl, and that the data set is actually accurate. And so you want to check for things that are logically inconsistent, like a student says they're in grade 11 at the ABC primary school, you know there's something wrong. They might be age 11, but they can't be in grade 11. And you want to check that if they answered 1111, that you've entered 111. So you want to do some checking and a light check. I have colleagues a colleague from the States. She double checks everything. 2 people enter everything, and if there's any discrepancy between the two sets are compared against the original. Very thorough, very rigorous. Having been sure that the data in the spreadsheet reflects the data that the person gave you, garbage in, garbage out, has been eliminated, we then start to do some basic statistical analysis of the data. One of the things we check for is normality. Normality is the idea that in a large group of people, responses tend to be distributed in the classic bell shape. That is, that most people will answer around the middle and a few people will be at the extremes. Now, it's possible for some variables to be very skewed one way or the other, or very peaked or very flat. And some of the statistical analysis we want to do later on requires that the items fit the normal distribution. And there's some tolerance on that, and if they're too far, well, we need to correct it. Either drop it, trim it, or transform it, which are things that are very technical and would need to be explained with pictures and a computer program to show you how that is. But you know that if the data is reasonably normal and people have behaved in a reasonably normal fashion, anything we want to do beyond that, it will be legitimate. Assuming the data are normal, we would want to check the simple descriptives. And by descriptives we mean things like the mean, the minimum, the maximum, the standard deviation, the median, the mode. What we're looking for is, are there items that are really divergent from others? And if they're divergent, there might be a data entry problem. Something that all the people who had answered 3 suddenly had been entered with, sorry, not all the people. Even if one person who should have got a 3 was given a 33, that would have a huge effect on the standard deviation, the mean, and the minimum and maximum. And you would suddenly go, oh, that's wrong. And so you would need to go back and say, well, either this guy is really weird, or we need to remove him, or we need to fix it. So tools like that to make sure that you're dealing with a believable data set.
Once I've looked at my data and I'm fairly confident that the data is behaving in a normal way, and I feel happy with that, I go to the analytical stage.
Yes. The goal here, when we create questionnaires or when we adapt questionnaires, what we're looking at is a group of questions around a common theme. And each of those themes, sometimes called a scale or a factor, has a set of items. Usually in good questionnaire design, it's at least 3 questions to as many as 6 or 8 questions around a common theme that previous researchers have said these things group together. As an example of survey development, consider the following list of 11 statements. These were created in order to find out from New Zealand high school students their thinking about the nature of assessment. Students get assessed, so it seems important to understand what that assessment means to them. In order to do this, a series of questions were drafted, and students were asked to indicate how much they agreed or disagreed with each statement. Now, the statements appear in a random order, but upon close inspection of these 11 random items, 4 themes, or if the mathematics holds up, factors appear. The first theme, numbers 4, 8, and 11, all 3 of these items mention the words my work or my progress, meaning it's the students, and it's about evaluating or determining the quality of that work, checking progress, evaluating against criteria or achievement objectives, and so on. The second group, numbers 1, 5, and 9, have a different focus. Each of these 3 mentions schools and talks about their quality or worth or the value of schools. So this construct, in contrast to the first one, is focusing on using assessment to evaluate the quality of schools. The third construct, numbers 3, 7, and 10, show clearly that the student is having a rejection or negative or at least ignoring response to assessment. This is something I don't pay attention to. I ignore. It's not good. It's bad. It's awful. So this construct is quite different. It's a rejection, a treating of assessment as irrelevant, or at least ignoring it. And finally, items 2 and 6 show a quite different positive response to assessment. These 4 constructs create 4 themes in the survey. Now, the reason we want to group things together is twofold. One, it's too hard to understand people's responses to 30 items on a questionnaire. But if those 30 items group into 5 or 6 groups, then it's a lot easier to make sense of 5 things instead of 30 things. And we're not interested in your answer to question number 29. What we're interested in is your response to the construct or concept of, say, how much I like my teacher, or how good I think I am at school, not my answer to question 3. So simplification is the thing. And we're expecting items that we wrote or selected around a common topic to group together, to behave like each other. That when I'm reading them, when the people answering my questionnaire, every time they see a question on a similar topic, they behave in the same way. And in order to find out if people behave the same way, we have to look at the statistical properties of the numbers they gave when they answered those questions. And the key notion is the idea of a correlation. A correlation is a very simple idea. How do they go up and down together? For example, it's unfortunate, most people as they get older get fatter. Your weight goes up as you get older. Those are 2 correlated variables. Now, there are some people who stay skinny, and there are some people who are fat really young, but for most people, these 2 variables are correlated. They behave in a similar way. They're driven by a similar underlying construct. In the same way, our responses to a set of questionnaire items, we're looking for that thing that drives them to behave the same way. And we do this by looking at the correlation matrix. Now, if you've got 30 items, the correlation matrix is 900 data points, 30 times 30. Now, half of them are duplicates, so you can remove half of them, but it's still 450 correlations to look at, and nobody can do that. So we use statistical tools, and the most common procedure is called factor analysis, which allows us to analyze the pattern of correlations to look for things that go together, that behave like each other. And the assumption, we call it a factor or a latent trait, is that there is a common underlying mental characteristic could be emotional or psychological or attitudinal, that drives behavior around that set of items. So there's two things we're looking at there. Is there mathematical evidence that these items go together, that they behave in the same way across a large number of people? And when we look at the content of those items that have been grouped, does it look like they have something in common? And when we designed the questionnaire, we had a clear idea these questions are related to this topic. When we selected a questionnaire, those items were drawn from a common topic. So we should expect the items that group together mathematically also group together conceptually or thematically. And if they do, that's what we would call a factor. Having created 4 themes, we examined the statistical properties of the responses that people gave to these items. We expect items 4, 8, and 11 to be a group. In order to be a group, the statistics have to show that there is a strong interconnection between these items, in that the people behave in a similar way when they answered them. Now, factor analysis produces a set of data which says, here's how much this item and others are explained by a common trait. For example, for items 4, 8, and 11, the data display shows that the common trait, make students accountable, explains 0.66, 0.67, and 0.59, respectively, of these 3 items. In this case, what we're arguing is that the notion makes students accountable predicts or causes a change in people's responses to each of these 3 items that we think belong together. If your score were to go from 3 to 4 on the trait make students accountable, is the reason or purpose for assessment, these formulas say that your score for number 4 would go up 0.66 of a standard deviation, 0.67 of a standard deviation for number 8, and 0.59 of a standard deviation for number 11. What we're saying then is that we can explain a fairly large proportion of the behavior that students have in answering these questions. And in terms of explaining human behavior, being able to explain more than 10% of human behavior is a considerable advance or achievement. But in this case, the values show us that we've actually been able to explain around 36 to 40% of the variance in people's responses to the items. So we're explaining a lot of how students have answered each of these individual items by calling on this invisible idea that assessment is about making students accountable. So now I can say to you, based on 4 factors, that there are 4 big ideas that students have around the purposes of assessment. 1, it's about making students accountable. 2, it's about making schools accountable. 3, it's about being fun. Or 4, it's about ignoring assessment. So now I can look at how these 4 big ideas are correlated with each other instead of having to worry about the details of 11 separate items. We show these correlations between the 4 constructs or traits or factors using double-headed arrows, which we draw as arcs rather than straight lines. And what you'll see is that the first 3 factors have reasonably strong correlations one to the other. Reasonably strong and definitely positive. In contrast, the correlations from assessment is ignored are always negative and considerably smaller. In summary then, we can do a statistical analysis to find out when people read these items and respond to them, do they behave as we expect them to? Do they treat items 4, 8, and 11 as a common idea as we intended? Do they treat 1, 5, and 9 as a common idea as we intended? And what this statistical analysis has shown us is that that is the case.
For me, the mathematics is always the scary part.
Yes.
But from what you're saying, actually it's only reinforcing the impression that we might get from the data.
Exactly. I remember discussing with a master's student of mine at the University of Auckland, and I said to him, if qualitative researchers realized how many qualitative judgments that quantitative researchers have to make in deciding whether a factor exists, in deciding which items belong to that factor, in deciding is the evidence strong enough to say that this factor really exists, they would stop seeing us as devils with horns, because we're actually using statistical processes to support our reasoning about human behavior, and it's not cut and dry. There is an art of judgment and reasoning. I think the big advantage of quantitative research, besides its speed in survey research, is that we've developed over quite a long period of time, some at least 100 years with the correlation matrix, a set of conventions and standards about how to judge whether the mathematics is robust enough to support the argument that these items constitute a common shared construct.
Now, is there anything to help me? Do I have to learn lots of statistical techniques and lots of mathematics, or is there anything which I could find that would make it easy for me?
Certainly before the advent of modern desktop computers, yes, I'm afraid you would have had to learn computer programming back in the 60s and 70s, how to punch holes in cards and wait all night while the machine spat it out, or learn how to do very complex longhand mathematics before World War II. Fortunately, today there are modern software tools. Almost everybody who has a PC has Microsoft. If you have Microsoft Office, you have Microsoft Excel. Microsoft Excel will do with the mean, the standard deviation, the minimum, the maximum. It will help you check for invalid scores, invalid responses. It can help you to sort and resort things. Excel can help you get even a correlation. It's got all these tools built into it. However, once you want to get to something like factor analysis, you do need to move to a specialized software tool. And there is a bit of a learning curve with any new tool, but with the modern point-and-click Windows-based menu systems where you point and click and select, you don't need to learn syntax. You can be very powerfully dangerous quickly. Fortunately, there are lots of guidebooks and textbooks and online tools to teach you how to do it right. Your instructors will know how to do it right. So you do have to have the willingness to develop the confidence and the skills. It is a new set of skills. It's not just trusting your judgment. It's testing your judgment against conventions and standards and learning the tools to do that. So there's a logical part and a skill part. There is a learning curve. But it's, I have to say, I used to be an English teacher, and I was an English as a second language teacher. I didn't do calculus in high school, and I've learned how to do the mathematics of testing and measurement and statistical analysis like factor analysis as an ex-English teacher. So I don't think it's beyond any MEd student.